Well, good afternoon, everyone. My name is Tim Harder. I look after business development for Elastic Block Store and for Elastic File System. Our discussion today and the session that you're attending is STG306, which is a review and update on Elastic File System. Over the next 45 minutes or so, we're going to cover the motivations for why we built Elastic File System. With a little bit of help from Camtasia, we'll show you how to set up and administer and scale, Elastic File System. We'll talk through the general awareness of the security mechanisms and the security planes that are available for EFS. And we'll talk in detail about Amazon Elastic File System's performance model. The agenda is a pretty ambitious one to cover over the next 45 minutes. In addition to some of the EFS content, we have a guest presenter who's going to join us as well. Laz Vekaritas, co-founder of Clear Sky Data, is going to share a little bit about their new offering and how they're leveraging EFS in its design. We'll walk through the overview, the technical concepts of EFS. Laz will come up and share with us a little bit of his new art. We'll discuss in detail the file system security mechanisms, review the performance model, and then we'll stay around for any questions that you guys might have at the end. Before we get started, though, I just wanted to extend my thanks and the thanks to the team for coming out and seeing us today. I know making the trip out to Las Vegas for reInvent is a significant commitment of not only time, but of resources. We genuinely appreciate you coming to see us, and we try to advance forward the best content for you while you're here. So before we get started, what I'd like you to think about for just a minute, imagine if you never had to worry about space in your file systems ever again. Would it be easier for managing your day-to-day application stack? Would it be easier for managing your infrastructure stack if you never had to worry about provisioning, managing, or maintaining your file system? And I'd like to draw your attention to the bottom right-hand corner of the screen in terms of the available size. So the first time that you do a DF in a brand new created Amazon Elastic File System, you're going to have, for the very first time at your fingertips, a multi-exabyte file system available for use and consumption. Before we get started, I want to share with you how EFS fits into Amazon Web Services' overall storage portfolio. We got started in the storage business at the end of 2006 with the introduction of S3. S3, as many of you know, is storage that is feature invoked through an API, an object-based store that is accessible over HTTP protocols, and it's designed for application native integration. We introduced shortly thereafter, coming into 2008, Elastic Block Store. EBS is designed to support single EC2 instances. People use it for boot, for scratch, for user-managed file systems, and for user-managed databases. And we introduced Glacier about 3 years ago now. Glacier is the archive tier that was really designed to tackle cold and deep archive-based workloads at a very aggressive price point. That left an area of the market for us to apply a degree of innovation to, and that was bringing a file system surface natively inside of the AWS service perimeter that could be used to deliver file system capabilities to many different EC2 instances. So we think about it as complementary and additive to the line card offering that we have today. And the line card and the services are really designed to be able to address not only your classic data storage requirements, but also your contemporary for new applications that are being built. EFS is a fully managed file system for Amazon EC2 instances. It provides standard file system semantics. It works with standard operating system APIs. It's shareable across thousands of EC2 instances. Another talk is being given down the hall here that I'll refer you over to, an organization that just did a 40,000 core run against a single file system. Elastically grows to the petabyte scale, delivers performance for a wide variety of workloads, highly available and durable, and it's NFS v4 based. I think it's really important to understand why we built EFS before diving into its details, because our motivations really informed the design criteria and really informed the types of capabilities that EFS is going to be able to deliver into your environment. So why did we build EFS? We built EFS because today, running user-managed file systems inside of AWS, when you take your compute plus your storage plus your file system, if you have any requirements at the enterprise level for multi-AZ replication, management, this is hard, expensive, and a little bit wobbly, especially at scale. And there's other alternatives as well, which are really prepackaged appliances that are being deployed through many different vehicles. Easy, but there's a lot of caveats that go with it, especially at scale. And we built EFS so that you don't need to manage the infrastructure bits associated with file systems. But we didn't want to take an approach that we were just adding incremental capabilities. We wanted to take an approach where we were delivering, changing the game and delivering asymmetric capabilities for you. And if you take nothing away from today's presentation, there are 3 things that I want to share about EFS. It's simple, it's elastic, and it's scalable. And we're going to drill down into each one of these to a very good degree so that you understand what I mean by each one of them. Key takeaway, though, simple, scalable, and very, 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 very elastic and scalable. It's fully managed, so there's no hardware, network, or file layer that you as an administrator or you as an operator need to maintain. You can create a scalable file system in just a couple of seconds, and it delivers seamless integration to your existing tools and applications. That is, if your existing app can use NFS v4, it can integrate and be easily deployed with EFS. Leverages standard file system semantics and a very simple pricing model associated with it, so it makes it very easy to forecast your data storage spend. Amazon EFS is elastic. The file system grows or shrinks automatically based on the volume of content you put inside of it. So with EFS, there's no need to pre-provision the volume of capacity in the file system. Today, with other approaches, you have to declare how big you think your file system is going to be. When you grow into that file system, you have to take it offline. You then have to roll forward a snapshot and try to grow a new file system. And many of those operations are offline events or offline conditions. With EFS, EFS is designed such that you can start at 0 bytes, grow automatically to the petabyte scale, and when you're done with that content, delete the content and the file system will automatically shrink all online. And you only pay for the volume of storage that you're actually using and consuming. Again, no pre-provisioning penalty or pre-provisioning requirement needed. And Amazon EFS is scalable. You can start at 0 bytes and scale up to the petabyte scale. And the performance model is novel. We've equity linked the performance model to the volume of capacity that's inside of a file system. That is, as the file system gets bigger, it gets faster. As you remove content out of the file system, it goes back to a declared baseline, all without any type of end-user intervention or any type of administrative function that's required in order to do that. EFS is designed to deliver consistent, low-latency experience regardless of the number of clients that are interacting with the file system. If you've run file systems in contemporary data centers today, you know that as the number of connections scale, often performance declines. With EFS, the design intent is to deliver a very consistent performance experience regardless of the number of connections, and it's designed to scale to thousands of those. So why does this matter? We'll take a look at we'll take a look at why this matters through the lens of 3 different people who might interact with EFS. To the IT and administrative staff, this eliminates the need to manage and maintain a file system. And if you're an app owner, EFS allows very easy mobility between your classic data center environment and Amazon Web Services. So if you have a classic app today that required a NFS service or a network-attached storage service at scale, and you were hesitant to bring it over to AWS, EFS is what helps you do that. And for your business, because we've made it a very predictable and forecastable pricing model, there's no question as to what your cost of ownership is going to be for what is otherwise a very expensive tier in the classic data center environment. So we can give you we can give you a 36-month look at what your cost is going to be associated with EFS in a very predictable way. So let's get started, and we'll dive in here. So inside of EFS, what is actually a file system? The file system is the primary resource where you're going to store your files and store your directories. And you can create multiples of these file systems in each one of your AWS accounts. You access those file systems from an EC2 instance, or really a collection of EC2 instances. And the way that you do that is you mount the file system. It's a very simple mount command that's executed from your Linux command line today. And the file system appears like a local set of directories and a local set of files. And the NFS v4 is found in the majority of Linux distributions inside of AWS today. And where it's not, we give you tips and tricks on how to add those distributions to your Linux instances. And we walk you through command by command if you've never done it before. What is a mount target? A mount target inside of EFS is some new nomenclature. You might think about a mount target as a NFS endpoint inside of your VPC. So if you're familiar with other AWS technologies that deliver endpoints, think about this as an endpoint delivered natively inside of your VPC. And that is a location where your EC2 instances will interact with a NFS surface. What that means is we've delivered a very robust, highly available, highly scalable location where you interact with an NFS surface, and we put high availability and scalability at that layer such that it doesn't even have to be architected higher up the stack. And to access the file system from your instances inside of the VPC, you create a mount target, and I'll show you what creating a mount target looks like. We'll mount it on a client. And then that mount is done through a IP address scheme or through a very simple DNS name. So how does this all fit together? The couple of pieces here, the moving pieces that are critically important is the Amazon Elastic File System is natively located inside of your VPC. So any investment that you've made in VPC for risk reduction, governance, and control is inherited by Elastic File System. And you prescribe at a region level which individual availability zones will have access to EFS. And then your individual EC2 nodes interact with EFS for the purposes of computing, reading, and writing data. So really 3 layers, and we'll walk through each one of those in detail. But before we get started on those, there's 3 ways to set up Elastic File System. You can set it up through the management console, a point-and-click experience. You can set it up through the command line, and you can also set it up through an SDK. So whether you're a developer, an administrator, or a user of EFS, it's very easy and very simple to get started. Regardless of which topology or regardless of which method you select to deploy EFS and to administer it, whether it's the console, the CLI, or the SDK, each of those vectors allow you to create a file system, create and manage the mount points that are associated with them, tag a file system for the purpose of resource management, delete a file system securely by integration into Identity and Access Manager, and we'll walk through what that looks like. And you can view the details of them via tagging inside of your AWS account. So setting up and mounting a file system takes under a minute. So we're going to create a file system here in just a second. We're going to mount it. We'll create the mount target and declare which individual availability zones you want to have access to a given file system. We'll enable NFS on your client if it's not there, and then we'll run the mount command. So I said it takes about a minute. With the help of Camtasia, it'll actually take about 35 seconds here. And we'll stop and start along the way so that you can have some exposure to each one of the processes. So first thing that's going to happen here is you log into your console, and you'll notice in the top left-hand side, you'll see under Storage and Content Delivery, Elastic File System, and Elastic File System is available today in preview. So if you're a console user, very easy to get started here and very easy to browse to the new service. Once you click on it, you're going to come to an introductory screen, and we're going to walk through 3 specific steps. We're going to create it. We're going to declare who's going to have access to it. We're going to execute the command, and then we're going to go to the individual EC2 instance and mount that for production purposes. A couple of things happened when we clicked off to that next screen. The first thing is on the top left-hand side of the screen, these are going to query a collection of defaults from your VPC. So this is user-definable screens, but we pre-populate it with defaults out of your VPC, specifically the default security groups and the default VPC inside of your account. So this goes off and queries, figures out which VPCs you as the administrator have access to, pre-populates that VPC name, and then on the bottom left-hand side, the first couple of checkboxes are around which availability zones you want to present EFS to. This is really important, and some of the new and very interesting art that we've created around Elastic File System is its ability to be a multi-AZ reader and writer, read and write capable. So if you have an application that is functioning across multiple availability zones today, and you have different computing elements in zones 1 or zones 2 or zones 3, Elastic File System gives you the ability to interact with the common namespace across each one of those AZs. And an important attribute that we'll talk about in just a second is it's strongly consistent. So when you write content into EFS, before we acknowledge the write, it's available for other computing purposes, read after write purposes, and all of the availability zones that you declare you should have that the content should be written to. So in the next steps, what we've done here is we've said create mount targets for us automatically, create those mount targets in 3 availability zones that I have access to, put it with this subnet mask, with an automatic IP addressing scheme, and grab these security groups, these default security groups, to apply them to the create. Next screen, we have the ability to provide a user-ascribed tag to the file system. So we've gone through the effort of identifying the VPC that we want to place the file system inside of. We've queried for the default security groups associated with that particular VPC. We then selected which of the individual zones that we want to have access into. And now before we go off and actually do the create, we've got one step here that allows us to tag what the file system is for the purposes of billing and for the purposes of administrative functions. So if you go off and create a bunch of file systems, you know what this one happens to be, for. And for here, we'll just call this my first file system. Before we go off and execute the command for you, we'll give you one more chance to inspect it, and I'll take this from the right-hand side of the screen to the left-hand side of the screen. Which security groups do you want to apply to the VPC? Do you want to apply to this particular mount target? What is the IP address scheme and the subnet mask associated with it? Which of the 3 AZs do you want to have access to it, and what is the VPC in which you're going to place it? And then double-check the user-ascribed tag in the bottom left-hand corner. So it really took 3 or 4 clicks to get this far. It took 5 minutes to talk about it, but when you go through it the first couple of times, you can start creating this very quickly in under a minute time. File system has been created, gives you a readout of the commands that were executed, and now this file system is available for computing purposes from your EC2 instances. So we'll roll forward from here. Now, if you've never used a Linux command line, it could be daunting. What do I do next? How do I go off and access my file system that has just been created? And we give you some tips and tricks and hints on how to do that. So if you've never used the command line before, we make it very easy. We show you how to do the NFS package if it's not already installed on top of your EC2 instance, shows you how to go off and deploy that, and then shows you how to actually mount the file system. So we wanted to make this a very simple point-and-click experience for those that are comfortable managing a contemporary command line, but also for the new user to get started as well. And we also deployed a hints and tips page for the DNS naming scheme associated with each of those EFS mount points as well. So we just gave you a bunch of defaults. We queried for a bunch of defaults inside of the VPC. If you want to know the addressing scheme in order to mount them, we make them available here. And then on the bottom, as you can see, we give you a snippet that allows you to cut and paste that. And all you have to do is add it to your Linux command line, and you're off to the races. So the steps that we've taken to create a multi-exabyte file system, a file system that can scale to the petabyte class for you, really took under a minute. Doing this the old way, you'd have to go off and provision tons and tons of gear, deploy it in multiple physical locations, stand up a file system, manage that file system, hope that the communications for that file system were something that we're able to keep up with its scale. And we delivered that capability for you here in just a couple of clicks. Even though you've got a couple of exabytes of capacity that are available to you, don't worry, we only bill you for the space that you use. So we're going to talk about securing the file system and what surfaces are available for maintaining security and maintaining control against it. And then we'll invite up Laz to talk a little bit about some of the work that's being done at Clear Sky Data. So there are 3 control surfaces for Amazon EFS security: controlling security at the network layer, controlling it at the file and directory level, and controlling it on the administrative plane. We'll take each one of these in order. Controlling it on the network traffic is really a VPC capability where you have the ability to deploy VPC security groups and the network-based ACLs. So you get to prescribe which EC2 instances are going to have access to a particular file system. Next, at the file and directory layer, you have the ability to manage your user and group permissions, just like you always have on other file systems that you may have had previous exposure to. And then the administrative functions around creating a file system, deleting a file system, tagging a file system, we separate those functions out from between the administrative function and the user space function. And those admin functions are entirely controlled through identity and access management. And for those, we support both the resource-based functions as well as the user space functions. So what does that actually mean? In practice, what that means is only the EC2 instances that you declare inside of your security groups are going to have access to a particular file system. So this allows you to manage multiple file systems inside of your VPC securely. And this is what allows you to be able to very rapidly deploy a file system to a high security posture inside of your environment. So VPC, as many of you know, starts with a set of implicit denies. So what we're doing here is we're implicitly permitting which individual EC2 instances are going to have access to a particular file system. So here we've given an example of a VPC and 2 VPCs. And what we've done here is we've declared which particular EC2 instances are going to have access to a given file system. Security groups control which of those instances inside of the VPC can connect to the mount targets. So the security group either permits or denies a particular instance from having access to a newly created file system or a collection of file systems. And as I mentioned, Amazon EFS supports both file and directory level access permissions. So I think about this as a defense in depth approach. We give you a unique control surface inside a VPC that allows you to prescribe which instances are going to have access to it. Then you go to the individual host level itself and declare which individual users or groups are going to have access to a particular collection of resources. And then for the administrative functions around creating a file system, deleting a file system, et cetera, tight integration into IAM for those particular purposes. And as I mentioned, we support the access level functions and as well as the resource level functions inside of IAM. Just a couple of quick FAQs, and we'll invite Laz up here to talk a little bit about the work that they're doing at Clear Sky. Does EFS support ACLs? Not today. Does EFS support NIS or NIS+? You don't need it, but if you have it in your environment and you want to integrate, we'll support it. Does it support Kerberized auth, or does it support encryption today? Nope. These are priority features for us. And as soon as we get to a general availability release, you'll see us quickly introduce encryption capabilities. And one of probably the most common question is, does EFS support Windows? And I'll just ask you to stay tuned on that, and we can talk later about what that's going to look like. So we'll invite Laz up here to talk a little bit about Clear Sky Data, and then we'll dig into the performance model of EFS and how to get started. Thanks, Laz.
Thanks, Tim. So I'm Laz Vakaridis. I'm the CTO and co-founder of a young company called Clear Sky Data. We are a couple of years old, and we very recently announced the availability of our service. This is a company out of Boston, and we're very, very focused on the enterprise storage space. What we deal with today in enterprise storage is the very, very large, complex silos of equipment sitting in data centers worldwide that are required by enterprises to maintain durability. So you have to protect against the failure of a device like a disk. You have to protect it against the failure of the weather or some other disaster, so you need to stand up another silo somewhere far away so that you can protect your data. And then you also have to protect it against just general user stupidity, so you have to have backups. And so once you do all of these things and you think you're all done, you have to do it again every 2 or 3 years because your equipment is obsolete, and so you start the cycle all over again. Our vision, our goal at Clear Sky Data is to make this whole process look like just plugging into a network. We make all of this stuff go away. And the way we're doing that is through what we're calling a global storage network, the goal of which is to provide high-performance primary storage capabilities at the edge in data centers worldwide, but with the economics and scalability of the Amazon cloud. We are offering a metro-based service, so we do it inside of metros, and I'll get into why we actually have to do that. But we are going to be deploying metro by metro. We offer our customers an SLA. Obviously, no one would take something like this unless they had some assurances that it actually is equivalent to physical storage in terms of availability, performance, and durability. And we also manage all of the drudgery that comes along with all that storage behind that wire. So it's not just primary storage. High-performance primary storage is just one of the requirements that enterprises have. They also want to be able to not worry about disaster recovery. They don't want to worry about backup. All of this is built into the system. Now, in order to deploy this, we actually have some very, very tight latency constraints. And because we have been, as yet, unable to speed up the speed of light, the only way in which we can actually offer customers the level of latency that is expected of primary storage at these edge locations is to build out within a couple of milliseconds of them. So we're building out a network of points of presence across the United States where we can interconnect with local data centers and offer connectivity into our service. We intend to be always within 2 milliseconds of the customer. In fact, all of the resources that the customer's applications are actually interacting with are generally within that data center, which is 2 milliseconds or less from them. So you get the general latency capabilities of local storage. However, the actual storage is quite distributed. This is our architecture. And what goes on behind that wire is quite interesting. So we start out by building out these points of presence in each of the metros. They're in highly connected buildings. We have software that runs in multi-tenant environments inside of commodity hardware in a small stack inside those data centers. And we also have a fairly sizable multi-tenant cache. And this is what lives within that 2 millisecond boundary. And it's largely intellectual property that we built ourselves as basically a storage array running as software. However, the way you have to think of this network is that it's just a network of geographically distributed caches. In order to get the durability that enterprises require, we're leveraging Amazon S3. And we're interconnecting directly into Amazon to actually get that capacity. And Because of the ability to get 11 nines of durability, this allows us to substantially bend the economics of managing primary storage. On the front end of the system, we interconnect again with private connectivity into data centers in the local area. Any customer that needs access can get it either inside their building, or we can actually give them an appliance inside their rack if they need to. We support largely all of the storage protocols that you would expect a SAN device to, so you get a very, very broad array of connectivity options at that edge. And we do a fair amount of data management there as well. So, because we are leveraging AWS not just as a backing store, we've taken advantage of a huge number of innovations that have come out of the AWS team. So this is truly an AWS Leverage service. Of course, we start with S3. As I mentioned before, we have a very, very high durability object storage. It allows us to take advantage of the durability that it offers so that we don't have to have durability inside the caching network. We run everything inside of our own VPC. This actually allows us to isolate our customers' data from the world at large, and it allows us complete isolation and lets us do a lot of the things that we need to be able to do from a security and encryption standpoint, and also from a certification standpoint. We are very, very heavy users of Amazon Direct Connect. Every one of our points of presence has multiple lines being drawn down into either the Northern California or Virginia locations of Amazon, we're connecting into the appropriate data centers at all these locations. This is very, very important as well because, again, we are a latency play, and low latency connectivity that's dedicated is the only way that you can make something like primary storage work efficiently. And finally, there's the management plane, and this is where EFS comes in. So, one of the things that we're basically telling our customers is that you don't have to worry about all this management anymore. So there are two different forms of management in this type of service. As you can imagine, a customer wants to be able to do certain things like provision storage, assign resources to users, et cetera, et cetera. And so they need to have a piece of compute, which we leverage EC2 for, and that is a website that they actually access for their own storage infrastructure. And that is the customer-facing side of the management infrastructure. We also have our own operations team. Customers of Clear Sky Data are not supposed to have to manage infrastructure. We do that for them, but that means that we have to manage our own infrastructure, and we have to build a fairly rigorous and expansive set of monitoring and management tools for our own operations staff. For this reason, we're leveraging EFS as the storage element for our management plane. As one of the many things that our customers are asking us to do is to keep track of extended long-term statistics for storage utilization. They want to see logs. They want to see who's accessing what for extended periods of time. And if we actually had to pre-provision chunks of storage for unknown amounts of data, we would have a very, very serious management problem down the line. EFS, because of its elasticity, allows us to just point file share to each of these instances, and it just grows. Obviously, to the I'd never seen exabytes before, but I'm very happy that we're going to go that far. The EFS also has a very, very good performance for us, and it allows us to run the types of analytics that we need to be able to run in order to run our network. A lot of what we do internally is analytics-based, and it's based on the idea that a very, very small amount of your data is actually being accessed at any point in time. And we are very computationally heavy, and we need to crunch a lot of data very quickly in order to determine where anything should sit. So this is how we're leveraging EFS. One of the interesting aspects of what we do is that because we are backed by EC2 and we are also integrated so tightly with AWS services, we are allowing customers to expose their data inside of EC2. So it's actually a very, very interesting use case that we are introducing to our customers, which allows true hybrid mobility. If you're running in Boston, Massachusetts with a set of workloads, it's very easy to switch them over and have them run inside Amazon EC2 because your data is actually there, and we can provide high-speed access regardless of location. So that's it. Thank you, Tim.
Thank you, Laz. We sure do appreciate you coming out and sharing some of the new work that you guys are doing at ClearSky. In my position, I'm fortunate that I get to see a lot of deal flow from new storage ideas and new storage companies from all over the world. Laz and his team have delivered some of the most interesting capabilities that I've seen in a very long time, and I'd encourage you to take a real hard look at it. In addition to the work that Laz and the folks at ClearSky are doing, there's two other sessions that I'd highly encourage you to take a look at that give you a real practical look at how end users are deploying EFS inside of their environments today. CMP 404, which is a talk being given by Disney, and 405, which is a containerization approach, which is being delivered by Sony. So we're gonna spend the next little bit and the next half of the rest of the presentation focusing on EFS's performance model. I mentioned at the very opening of the presentation that the performance of EFS is linked directly to the size of the file system and the volume of data that is under management inside of that file system. So as a file system grows, the amount of resources that are allocated to it for throughput and for IOP density increases. And as a file system gets larger, we deliver more throughput to that particular file system. And many workloads, as you know, inside of your environments today are spiky. So what we've actually done is we've delivered a baseline level of performance against the file system, a minimum floor, and a high watermark against the file system, or a burst mode, that we expect the file system to operate in the majority of the time. And the way that I would think about this, if you've been previous users of GP2, you've been exposed to this model before. This is the idea of delivering a very consistent performance experience based on the volume of capacity and allowing you, in fact, to burst to double that level of performance on an as-needed basis. So we deliver a very consistent baseline performance as your EC2 instances require more throughput out of a particular file system. We make those available so that you can complete the job as fast as possible, and the file system automatically reverts back to a particular baseline. The two numbers to really take away from the slide, and we'll walk through here in detail, is for every 1 terabyte of capacity inside of a file system, we deliver 50 megabytes per second of throughput as the baseline, and 100 megabytes per second as a high watermark, or burst mode. So what that means is for every 1 terabyte of capacity inside of the file system, 50 megabytes per second is the absolute floor that will deliver to you for that particular resource. And in burst mode, we'll deliver to you 100 megabytes a second per terabyte. And those numbers scale and decrement linearly. So if you have a 10 terabyte file system, we'll deliver to you 500 megabytes per second on the low end and a gigabyte per second on the high end. And this is really designed such that you can start with a very small file system and scale up to the largest of file systems on an as-needed basis, and having a very consistent performance experience that comes regardless of which end of the curve you're operating at. So whether it's the entry-level file system size, which in fact we overpopulate the volume or the number of credits that are effectively available to you to draw down against, or at the very high end, which is really one that really allows you to take advantage of the elasticity of the file system without having to manage any other mechanism from a provisioning perspective. So as the file system grows, it's one that unlocks additional resources for you in a very predictable way. And as your file system capacity needs revert back to some known good baseline, we'll take back those resources, we'll stop billing you for them, and really this is designed such that the workloads can be dynamic and can be very flexible and take advantage of the elasticity of the system so that you can deliver the lowest total cost inside of the environment. So what types of workloads is EFS appropriate for, and what types of workloads should you be thinking about consuming with EFS? Well, EFS is designed for a wide diversity of workloads and really a wide spectrum of use cases. We started with solving for an apex problem for high throughput and parallel I/O file system use cases. So on the far left-hand side of the screen, you'll see use cases that are really focused on high throughput and effectively are large file operations. These are things like genomics and big data and scale-out jobs. Many of you have jobs like this, and in fact, many of the early adopters for Elastic File System have these types of characteristics. So when we started working on the performance model, we worked on a performance model that was very appropriate for these very, very, very large jobs. But not everybody has those types of jobs or has those types of requirements at the high end. And we wanted to make EFS appropriate for a wide diversity of use cases. So we're actively working on another collection of use cases right now. We're working on those around metadata-intensive jobs. If you have a collection of jobs that have a high volume of get adders or a high volume of set adders or a high volume of opens and a high volume of closes, we're working on delivering a low latency experience and one that can deliver a very consistent performance experience for low latency and serial I/O sensitive applications as well. So when you think about EFS, think about it for a wide diversity of use cases, those that are appropriate for large block, large sequential, what you might historically have defined as scale-out jobs. But also think about it for low latency, serialized I/O workloads, things like software builds and the metadata-intensive operations. We're ready now at the very high end and the very apex part of the problem. We're actively working to deliver the capabilities at the other end of the spectrum, and you'll see us continue to deliver more and more job types during the preview period, which is going on right now. So we're going to talk about the regional availability and durability of EFS. Today, EFS is available in our PDX region, which is US West 2, physically located in Oregon. When we move to general availability, we'll be in US East, which is Northern Virginia, and in EU West 1, which is in Ireland. I mentioned it at the top of the talk. We visited it at the middle of the talk, and I want to re-emphasize it. For Amazon Elastic File System, data is stored in multiple availability zones, and we take advantage of those multiple AZs for the purposes of high availability and scale. If you have job requirements where you have resources in multiple AZs and need to have access to the same file system, this is the capability that EFS delivers to you. And it delivers it to you in a strongly consistent manner. That is, as soon as your EC2 instance writes data into EFS, before it's acknowledged back to your application, it is stored and persisted in multiple AZs, such that compute instances in those other AZs can interact with the content and move on for additional computing purposes. So every file system object, those are directories, files, links, symlinks, et cetera, are stored redundantly in multiple availability zones. And the reason that we did that, again, was for the strong consistency model, such that we could deliver multi-zone computing across file systems for the very first time at the cloud scale. So we're going to wrap up, but before we do, I'm going to talk a little bit about TCO, because you can't have a enterprise storage discussion at scale without talking about the cost of the service or talking about the total cost of ownership for storage and how it relates to market alternatives that are available to you. So we took a 1 terabyte TCO example here. I'll start from the left-hand side and work my way to the right. You can deliver and deploy a file system capability inside of EFS, inside of Amazon Web Services today, and you can do it at scale. It takes a couple different moving pieces in order to do that. It takes a compute instance in an individual availability zone. It takes a collection of storage resources at that AZ. It takes a file system that rides on top of it. And if you have any type of enterprise-grade availability or durability requirement, you've then replicated that infrastructure into 2 or 3 additional AZs. And for transparency here, I took an M3 extra large, 3 of those, 3 terabytes of EBS GP2 disk, and modeled for some inter-AZ replication for a busy file system over a monthly basis. And when you sum up those moving vectors today, these are real hard costs. These aren't any clever math or soft costs, et cetera. When you sum up all these costs today, it costs you about $1 a gigabyte using these portions of the infrastructure that I've shared with you. There are capabilities that deliver it in an appliance-based form factor, those that can be rapidly consumed, but there's a per-hour charge associated with them. There's a storage layer associated with them, inter-availability zone replication traffic associated with them. And again, model dollar for dollar, config for config. When you look at user managed versus appliance managed, it's about a 4x uplift or a 4x differential. And then you have the ability to run this inside of your classic data center if you're still in the data center business. And you'll hear many different customers this week talking about retiring their data centers because of the significant property and plant expenses associated with it. You'll notice that an on-premises all-flash array configuration, when you think about raw to usable, that is, including for data protection, the cost of funds that are associated with buying it, utilization and co-location, and this is only in a 2-site mirrored configuration. You'll see these configurations roughly 60 cents a month per gigabyte, rough and tough, depending upon the discounting levels you'll see from your vendors. We put EFS in a price band that I think is very attractive, both for the native AWS user and for the user that has storage on-premise in your existing data centers today. So whether you're a net new user to AWS and you have workloads that you need to migrate from existing NFS repositories, or you're an existing Amazon user and you need to build and operate file systems at scale, I think the price band that we put Elastic File System into is very interesting and, again, very predictable, because that 30 cents per month is the all-up number based on the capacity that you consume. We're not going to bill you for the multiples of exabytes at the 30 cents per month per gigabyte. We're going to bill you for the capacity that you use and for the length of time that you use it for. If you have an interest in testing Elastic File System or using it in preview, or you want to learn more about it, I encourage you to browse to aws.amazon.com/EFS. And if you want to test it, you can click for a preview invite. We'll evaluate those as they come in, and we'll get space set up for you just as soon as we can. Before you go and before we depart, we'll stay here for the extended EFS team. Will come up and we'll take some questions from you if you have them. But on behalf of the team, I want to say thank you very much for spending some time with us. I want to say thank you for making the trip to come see us here in Vegas. For everybody who's watching over the web, I want to thank you for investing the time to learn a little bit more about Elastic File System. And please remember to complete your evaluations and surveys. Thank you very much.